Thank you, everybody. Yeah, this is my first talk, so be extra nice to me. A little bit about myself is that I spent a couple years in the agricultural technology industry, and now I'm in government contracting, so a very wide array is my background. A lot of this talk kind of came from the idea of CPPCon last year. Someone gave a cool talk about testing theories, and this one was really interesting, but they kind of blew over it a little bit faster than I would like, and so today my goal is to kind of dive into it and really give you guys the deep dive that I wish I had. Anyway, so first things first, what is mutation testing? I'm sure you guys are all very eager to hear this. Mutation testing is an approach that will go in and deliberately change your source code to evaluate how good your test suite is. For me, I call it test validation. A lot of people will look at this different ways, but the main goal of this is to prove that the tests you wrote are testing what you think they wrote, or what you think they test. And so, at least when in my first job, we really did not have a test suite. It was lacking, it was very embarrassing. At my current job, we have a great test suite, but we have a lot of requirements surrounding code coverage. And so we'll write tests for code coverage, but we'll never actually see if the tests we wrote are good outside of manually reviewing them in an MR, which, don't get me wrong, reading a test suite can be very good and helpful, but understanding a test suite is a little bit more difficult, especially when you are not the person that wrote the feature. So for this, it's mostly just sitting down and saying, okay, I can look at the code looks good, I can look at the test looks good, and there are two different ways to validate that everything is good outside of me seeing it: mutation testing and code coverage. Now, for the developers, I want to show you an example because I can say something, but it's a little bit easier to actually read the code. Very simple, C++, someone has seen this at some point in their life, a simple addition function. And here we'll see that someone wrote a test to add 2 + 2. And I'm sure you guys can kind of see an issue with this, but let's say some very new developer has no idea how to test this function, but there is a test, the code coverage is there. And so you'll kind of see that this test will pass. Even if we don't think it's written very well, it still passes, it gets the code coverage. By my company's standard, this would be an acceptable test. But if you add some mutation testing, let's dive into how you can actually prove that that test is not effective. And so going back to our example, mutation testing is going to look at your only line of source code and say, all right, I want to deliberately change this line, and it's going to say multiply. And so from here, we can look at our test suite, and our test suite is still going to pass. And so mutation testing will sit down and say, you have written an ineffective test, there is a mutant in your code that still exists. And so you can kind of bring this to upper management, anybody who's not a developer, and actually have evidence that says the test suite is ineffective, unfortunately. We need to reevaluate this MR, we need to reevaluate these tests. It's not quite what we thought it was. Hindsight's always 20/20, but it's good to catch things kind of before they get into production, and so mutation testing really has a benefit there. For this, test still passes. Something really important to, I guess, also acknowledge about this is that, we'll get in the next slide, never mind. Okay, here we go. Okay, so mutation testing does have a lot of benefits. I want to talk about how this will affect kind of mono repos as well as submodule architectures. If you guys have custom libraries and you're trying to export them, how do you prove that what you are delivering is good and meets all of the requirements? It should be able to fit into all of these different structures that you guys have, but obviously every single code base is very unique, and so everybody has a different spot that they can add this mutation testing in. Some repos, if they are multi-level, you may want to add them multi-level. You may want to add it at the top level. You may say, I want my hindsight to be 20/20. I want to run it on the production code, and I only want to run it once every couple months. It truly is a kind of tool that you can use as you need it. My preference is before it merges and before it gets into production, but that's not always the way that things work. Some of the big benefits here are going to be that it does prove your test strength. It's going to validate your coverage. The big one for me is my experience has been that us as developers, we always make a lot of assumptions about what our code is doing and what the inputs are going to be. And our test suites definitely reflect those assumptions. Even let's say that you're going to do 0 plus 0 versus as your, test. So maybe this isn't quite a good example because you're saying, Emma, but our code is thousands upon thousands of lines, and there's no way that we can have hidden assumptions because we test every single function individually. I promise you, someone along the line has made an assumption. It's going to reflect somewhere, and it's going to be a little bit difficult to find unless you have this external tool that will come in and sit down and say, all right, no more assumptions. I want to look at the numbers. Another big thing about this is it's going to prevent fragile code, kind of going back to what we said about assumptions. And overall going to boost your testing quality. This is a big one I see kind of in my field as well as in my past job. We write tests and we test what we know, or we test the data we know we will get, but we don't test the data we know we won't get. If that makes any sense. Basically, let's say that our contract requires us to take in data format A. Okay, what happens if someone else isn't following their contract and suddenly my team is getting data format B? Is that going to break when it's supposed to break? Will we reject the data? Even if a field is formatted incorrectly in our input data, what does that mean for us? Will we be able to reject it? Or are we going to find some mutant in the code that's going to say, you've made an assumption, it's not really going to work out the way that you intended? Anyway, hopefully you guys understand some of the benefits, and I'm swaying you towards using this, but if you guys are ready to use this, I kind of want to acknowledge how to add it into your code. But specifically using open source libraries, because that is where we are. A little bit about this before I dive into the specific tools is, I'm sure we're all here because we love pipelines, okay? And so in my head, if you can run anything locally, you can put it in a pipeline, you can put it in a job, you can make it run synchronously or asynchronously. You can schedule it. So a lot of these tools, you're probably going to want to start by running it locally, learning the tool, and then putting it into a pipeline and figuring out what cadence is going to work for your contract or your repo. Kind of talking about when do you want to reevaluate any of these mutants that live in your code. Do you want to do it on the cadence of once a release? Do you want to do it per feature? And truly all of these tools are going to accommodate whatever needs you have, and they're out there waiting for you. So all you have to do is use them. First one that I actually got to pitch to my own company is made by Loman. If anybody has a lot of constraints for what C++ libraries they can use, this will be your best friend, because I have a team and a contract that's very specific about what libraries we get to use, but Loman is pretty widely accepted. And so this one should be pretty ready to go for anybody who's a little bit uncertain about what C++ libraries they can use. It does work with CMake. It has lovely documentation. I stole this graphic from them. Truly very beautiful. They have a really awesome example repo set up for you, so follow it along. They also have a web interface that's very interactive, where you can say what source files you want to run, what test suites you want to run. And it works, I believe, with most big C++ testing frameworks. I haven't had to do anything outside of ctest and boost.test. I think it does Google test as well, but don't quote me on that one. Anyway, this one also, I will say, disclosure, it runs on the magnitude of compile time. So anybody who has a super large C++ repo, please beware. But I also have a solution for you. This one does not run on C++ compile time. It has a way to specifically look into what source code it has changed and only recompile that code, and additionally, only run the tests correlating to the source code changed. So it doesn't do those full rebuilds. Again, yeah, it'll choose the tests. It also will run tests in parallel. So really good if you have an extensive test suite and you think that you are bomb-proof. This will be one that'll kind of run through very quick and help you out there. It also has a very beautiful way of displaying what type of mutation coverage you have and what mutants have been killed or not killed. And I believe that they have some form of integration for CI/CD already. I cannot remember if it is examples or if it has like a Docker image already built. But I do remember seeing that they claim to be ready to go into your pipeline. Anyway, and then same thing, very compatible with C-Test, Boost Test, and Google Test. And then the last one is for Java. C++ and Java are kind of my bread and butter, so anything outside of these languages, I'm gonna encourage you guys to kind of go off and find your own open source to help you out. But for Java, a lot of it will be with JUnit and TestNG. I use a lot of JUnit, so this one's very easy for me to integrate into my code base. It also works with Gradle, Maven, and Ant, also some pretty standard ones. Same thing with Mull, where it'll give you really beautiful detailed reports. It also has the selective testing, where it will only run tests correlating to the source code it has changed. And it does have the ability to turn on or off targets and packages based off of what you're worried about testing. So for me, I come from Java world mostly, and so I'd definitely send it straight into my center package, and I would be like, this is where all of my mistakes will be happening, is most likely in this package. Send it there. I want to hear all about what kind of mistakes or assumptions I'm making, because I know I am messing up somewhere, and so mutation testing has been very helpful with that. Same thing, CI/CD ready. And then it does have an active community and plugin. So for me, what this means is if anybody uses the JetBrains IDE, specifically the Java 1 IntelliJ, this can be a plugin straight to your IDE. You can figure out how to run this locally, figure out how to configure it in your IDE, and then automatically kind of transfer that into your pipeline. Hopefully that makes sense to the non-Java people out here. Anyway, and then I think that is a lot of my, oh, there's one more, Python. I did this for you Python people and I forgot about it. I know you're out there. Mutt, I forgot I found this one. Anyway, Python native. I believe it has all of the standard framework capability for Python, like Python's PyTest and unit test. Again, I barely write Python, so don't quote me on this. It does have a beautiful workflow, and it does have some really awesome detections, kind of similar to, I believe it was Mull, and then it'll also run in parallel, similar to Mull. This one is built in a little bit more with GitHub and GitLab. So for anybody who does pipelines or CI/CD support there, and you guys have to deal with a Python repo, I definitely suggest you guys look at this tool specifically. And then I think the highlight here was also that it excluded, you could exclude files and lines. I don't know if any of the other ones allow you to specifically exclude a line. So for Python people, if you know you wrote your bad first line, or you have a comment that doesn't make sense about the next line, you can absolutely exclude that and say, I know I'm making the assumptions. Don't prove that the assumptions are there. I'm not ready. And this will still run and be okay. Anyway, okay, that is the end for real now. Hopefully for all of you C++, Java, and Python developers, I gave you guys a tool that will allow you to go out and maybe integrate it into your pipeline, or if you are strictly a pipeline engineer, you can now go and propose this to all of the developers and say that this is what you're really looking forward to, and you think that this will help streamline your team at least a little bit. Anyway, any questions?
Thank you very much. I'll give her a hand. Would not have known it's your first talk. Great job.
Thanks.
Yep, any questions? Yep, all right, so let's go right here first.
Hey, thanks for the talk. The mutants require running the test suite for each mutant to see if it's killed, which is kind of resource intensive. Do you have any guidelines for like how much CPU you're willing to spend on mutation testing?
Personally, I have my own guidelines, but I truly think it's going to vary for each repo and what the constraints are for your system. I know that in my company and for my framework, we're very CPU and very memory heavy. So if we were going to set this up for all of our repos and not just a handful, if someone sat down and said like, hey, we're going to need 16 CPUs for just mutant testing, nobody would bat an eye. So I feel like that's a lot in terms of like a general software or one repo. So I might be a little bit skewed for that, but truly I think if you have the idea of what it typically takes to run your code or what it typically takes to run your test suite, I would expect it to be near that. I would not expect it to be exponentially higher. Awesome.
All right, next.
Hello, well done on the first talk.
Thank you.
There's lots of different mutations that could happen. Obviously, your simple addition example has only one real possible mutation. So my question is, if in a single function there are 100 different mutations that could happen, are these frameworks singling out one, randomly selecting one? Are you indicating that I want 5 or 10 or only one? And obviously, if you have 100 functions, is it introducing one to each and then parallelizing? I'm presuming you're not rerunning the test run for 100 different mutations, like running it 100 times.
Yeah, so great question. Each tool has a very specific guideline of what type of mutants it will create in your code, but they're all intelligent to some degree. They're not just going to go in and take out semicolons or, subtract a character in your variable name. A lot of them are targeted to be very deliberate. So for me in my example, when it was plus going to, that asterisk or multiply, it is a deliberate change. And so what you can assume is if you have 100 functions, it will only do one mutant per that sort of compile, which is why some of the streamlined ones are better, because it will compile and then kick off the relevant test suites, which will cut down on a lot of that time. And if it only recompiles that one function it's changing to look at those certain specific mutants in that one function, and then it's only going to look at those specific tests, it will really help a lot with cutting down your time. But if you go with some of those that aren't so intelligent, you're kind of going to end up with something a little bit chunkier, probably something you're going to want to schedule for the middle of the night and then see the results in the morning. Anyway, does that answer your question? Awesome.
All right, one more question. Good. Do you have one? Yeah.
Any insights on cost-benefit trade-off? Because certainly you're running a bunch more, and therefore costs are going up. What's the point? Do you any guidance on breakpoints for there, things that mattered for your organization in deciding whether or not to mutate?
Yeah, absolutely. So I do work as a government contractor right now, and something that I have had to explain to managers a lot is even though we are contractually obligated to do these subset of things, we have had to sometimes go out of the scope to do these other miscellaneous tasks because some contractors outside of our company will not complete their tasks to the fullest. And so what that kind of leaves is an open door for mistakes to happen for things outside of our contract that aren't necessarily our fault. And so something that can really do is allow us to make mistakes that we won't find for things that we're not always supposed to be doing, but we have to do in order to make the deliverable. A really great example of this is we are supposed to always get in a data format, but oftentimes the government has no way to validate that data format, and so we run into weird subsets of behaviors where we're making assumptions because we are contractually obligated to, and now it is our fault that we have made the assumptions. And so the benefit is that your company will not be on the line when mistakes are made that are outside your control, because all of these assumptions are going to be exposed throughout this mutation testing, and it will actually give you something hard, a printout that you can take to your customer, whether it be government or not, and sit down and say, like, these are the issues, this is how we can fix them, and this is how it will protect our company. Awesome. Well, thank you guys for coming. I really appreciate it. Oh yeah, and one thing, there is a luncheon here at noon for, yes, grab your box and come back. There is a cybersecurity luncheon here, noon. Okay.
Thank you. You did my announcement for me. I love it. Thank you very much.
Thank you.